I am Anil Kumar, and in this video we will understand how to find polynomial's coefficient. When x to the power of 4 minus x cubed plus x squared plus bx plus q is divided by x minus 1, the remainder is 0. And when it is divided by x plus 2, the remainder is 27. Find p and q. Well, you can use the factor theorem and solve it. I will show you how to use synthetic division and then solve it. It's kind of complicated but interesting. With that, we'll also get more conversant with this new learned method, synthetic division. So what we'll do is, first we'll divide this polynomial by x minus 1. So in synthetic division, we write the coefficients, right? So the coefficients of the polynomial are 1, this is x to the power of 4, then minus 1 for x cubed. For x squared it is plus 1, only 1 was sufficient, plus p, and then we have q. So these are the coefficients, right? And when you divide by x minus 1, that is to say we'll divide by 1, we get a remainder of 0. So what you get here is 0. How will you get 0 here? You will get 0 if we have minus q here. Correct? Now with that, let's begin and divide. So bring down 1, multiply by 1, write it there, add them up, multiply by 1, correct? 0, add them up, 1, multiply, get it there, you get p plus 1 here, right? P plus 1. Now from here, 1 times p plus 1 should be equals to minus q. So you get one of the equations. Let me write down this equation as p plus 1 equals to q. I hope that is important, right? You've understood that aspect. Now what we will do is, we'll do synthetic division with the other term and then see what is the relation which we can get. Once we have two equations, then we can solve them simultaneously and find the value of coefficients p and q, right? So again, we have 1, minus 1, 1, p and q. Now when it is divided by x plus 2, the remainder is 27. So this time we are getting remainder of 27, right? How will you get remainder of 27? You can get remainder of 27 if we have a term here which is minus q, so when you add q gets cancelled, and plus 27, of course, only then you'll get here, so plus 27. That is how you can get remainder of 27, right? So let's begin by x plus 2, so that means dividing by minus 2. So it 1 multiply by minus 2 gives us minus 2. When you add them up, you get minus 3. Minus 2 times minus 3 is plus 6. 1 plus 6 is 7. 7 times 2 with a negative sign is minus 14. When you add it, you get p minus 14, right? Now that gives us an equation, and this time the equation is minus 2 times p minus 14 should be equal to minus q plus 27. So that is the equation you get. Now earlier you got an equation, well, this was minus q. P plus 1 should be equal to minus q. So we have minus q is equals to p plus 1. So we'll substitute this. This is my equation number 1. That is my equation number 2. So we can substitute this equation. Minus q is p plus 1, minus q. I forgot to write minus 1 earlier. That was a mistake. Let us correct it. So instead of this minus q, I'll replace it with p plus 1 and then solve. So what do we have? We have minus 2 times p minus 14 equals to, instead of minus q, I'm writing p plus 1 plus 27, correct? Now we can solve for p from this equation. So this is, let us say, p plus 28, correct? So this is minus 2p, and minus makes it plus, plus 28, equals to p plus 28. Now that gives us p equals to 0, right? That p equals to 0 can only satisfy this equation. So we have p as 0 now. So let me call this as equation 3. If p is 0, what is q? Let me substitute 0 here. 0 plus 1 is minus q, and therefore q is minus 1, correct? So we get our answer. The answer is p equals to 0 and q equals to minus 1. So that is the answer for this particular question, correct? I hope you understand and appreciate the steps. The steps are synthetic division, right? So divided by x minus 1, you should ensure that the remainder is 0, which you can get if the last terms are as written here. When you divide by x plus 2, remainder should be 27. You will get 27 by adding q and minus q plus 27, right? And now you know the technique. Get two equations from these two, solve for p and q, and write down your answer, right? Of course, you can use the factor theorem and solve this question also. It's all up to you. At times in the test, it may be mentioned that you cannot use the factor theorem to solve. In that case, we are left with only one option, and therefore it is important to know a couple of methods when you go for the test. I'm Anil Kumar. You should subscribe to my videos, learn, and go ahead and score good marks. Thank you and all the best.